All right.
Cool. So thanks everyone for coming. Thank you, Yammer, for the opportunity to speak here. We originally, I think, touched base way back in February, so it's been a long delay from when we initially touched base to when I actually got here to talk. A lot has sort of happened to Yammer since then. We're no longer just Yammer, we're now Yammer plus Microsoft. It's kind of a big deal for us. 4.5 years as a company, relatively small. You know, when I joined the company a little over 2 years ago, we were 72 people, I think. We got acquired at about 450. Last year, we tripled headcount, users, and revenue. So it's kind of a crazy ride that we were already on, and then we picked up by Microsoft in an acquisition. And now some of the expectations that are on us there, it's like there's sort of no end to this hockey stick for us. And so it's sort of important for us to talk a little bit about Dropwizard. Dropwizard has been sort of a huge catalyst for a lot of the work that we've done in terms of growing Yammer. A lot of what Yammer used to be built on was pure Rails. Rails was only going to take us so far. Dropwizard was sort of the next step for us in terms of moving stuff off the Rails stack, getting individual services tealed out. So I'm very happy to be getting out to talk about this. This is actually my first talk on Dropwizard, so hopefully this goes pretty well. Don't hesitate to ask questions in the middle. Don't wait till the end if you don't want to. I did a talk last week. It seemed to go pretty well with a lot of questions in the middle. So if you want clarifying questions, you want to just dig into something a little bit deeper, feel free. So what on earth exactly is Dropwizard? How many of you before the meeting had actually heard about Dropwizard? The third of the show of the room. How many of you have actually used Dropwizard? Maybe about a quarter. Cool. That's actually fantastic news. We'd love to hear about people using Dropwizard. I'd be curious to hear later on what all of you are using it for. When I started at Yammer, we didn't actually have Dropwizard. We originally had 3 services that we sort of built, and we sort of cobbled together a bunch of things, and we eventually started distilling a little bit of a pattern out of it. But in terms of what is Dropwizard itself, we'll step back a little bit to talk a little bit about the name. I don't know if any of you are actually familiar with this particular cartoon, but what this cartoon tells us is that there's a very nice gentleman. He's walking down the street. He knows, oh, there's a drop hazard here. Oh, and something called a Dropwizard. And the Dropwizard shows up behind him and politely shoves him off of the cliff. So what this tells us that a Dropwizard is that he's some bearded jerk in a pointy hat. Or there's possibly an alternative name for it, which is our Dropwizard. Which is that it is a Java framework for developing OS-friendly, high-performance RESTful web services. Like I said, it started out at Yammer as largely a bunch of copy and paste. And when I started there, we had 2 services. I started working on the 3rd service when we got there. And Koda Hale, our infrastructure architect, and I were sort of at the time looking at it thinking, there's got to be some high-level things we can begin distilling out of what we've been doing in the 1st service, the 2nd service, and the 3rd service. Because ultimately, what would happen is the 1st service would start working. We'd begin work on the 2nd one. We'd copy a lot of the concepts into the 2nd one. We'd improve on it a little bit and think, oh my god, we should go back and fix this in the 1st one. We eventually started doing it with the 3rd service. And you have to say about abstractions, by the time you get to the 3rd one, you should be able to distill a pretty good, simple abstraction from the 3 of them. So this is what we did. By service number 3, we started to identify, distill a pattern. And that abstraction is what became Dropwizard 0.0.x. We've still actually not kicked out a 1.0 version of Dropwizard yet. We think it's still in very formative stage. So today we're actually on 0.5. The one in code is planning to kick out 0.6. So what exactly was the pattern that we actually distilled from this? And you can kind of see that it's extracted here from the website that we have, which is that it's configuration, it's metrics, it's logging, it's operations, HTTP, and JSON. If you want to sort of distill this down a bit. And so if we start kind of digging into each one of those things one by one, starting with configuration. Configuration starts with the YAML configuration file. Dropwizard can actually consume a JSON configuration file. It'll do either or. We tend to stick with the YAML version. The YAML version tends to be much more human readable. It's easier to edit. It's more friendly, shall we say. You're not sitting there trying to make sure, are these curly braces, are they balanced? Do I have a missing comma on the end of this particular one? YAML is a little bit more friendly to the human eye. And so this is an example of very basic Dropwizard configuration file. So you've got a little bit of data there configuring the HTTP aspects of this. So the port that you want to run your application on, the port that you want to run the admin console on. And then the rest of these, the other 3 here, are application configurations. So I've got one called foo, which is a string. I've got bar, which is a duration. We'll talk a little bit about that in a moment. I've got baz, which is a number. So you can configure it, you can go deeply nested, you can make these things so that you've got all these wrapped up under its own namespace. You can deeply nest the namespaces. One of the things that Dropwizard has support for is configuration validation. And this is something that's come about in some of the more recent versions of Dropwizard. Old Dropwizard used to only consume JSON, and it would supply it to you in this blob that actually was a lot like interacting with a JSON node from a lot of the JSON libraries. And it was very, I wouldn't call it nice, but it was very simple. One of the problems with it is that you ended up doing a lot of the validation in your application. So your application would have to traverse from node to node to node. If there was no node along the way, your application had to cache that and deal with it, figure out is this a fatal thing, am I missing a default that I can apply here? As it was traversing, it would find a certain node that it expects to be a number, it gets it back as a string, it's got to throw some other stuff. Dropwizard in the new versions allows you to do configuration validation, which means that you can actually define a configuration class and all the properties on it. So here we have the food, the bar, and the baz. And there's annotation-driven validation here. So we have a string property called food. And there's a not blank on it which says this can't be null, it can't be empty, there's got to be something in it. There's a duration here. One of the nice things about the new Dropwizard is that durations actually are high level. They're high level citizen. They actually exist as a duration, not just some nebulous number. And where this comes in handy is when you're doing things like, if you're talking to another service and you want to set a timeout on it, you go and you put the number in there, and you've lost all notion of what the unit of time is. And so you have to make sure that you do things like, you want to call this timeout millis or timeout seconds, so that it's very clear to the application, the person writing the code, what units it's in. It's very clear to the person writing the configuration what unit it's in. The nice thing about the duration class is you can actually, if we pop back here, you can actually configure it in terms of time. So I can say 60 seconds, or I can say 1 second here. Dropwizard will parse it and turn it into this duration object. In addition, you can constrain it to not null. And when this actually makes its way to the code itself doesn't have to care what units it was input in. The code itself can say, I want to take this duration and I want to convert it to milliseconds because I have to go apply it to a library that takes milliseconds. So duration was a really nice answer for us. The last one, the long baz, you have the ability to do min-max validations so that you can say, not only does this have to be a number, but it has to fall into this inclusive range. And if it doesn't, if none of these, if any one of these validations fails, Dropwizard will actually fail to start immediately. In the old configuration world, it would conceivably not fail until runtime. Like if you receive an HTTP request, that request hits some bit of code, that code then goes and digs into the configuration to try and pull a value out of it. It then fails, your service throws back an HTTP 500. You've then got to be aware that your service throws back HTTP 500s to know something is wrong. Whereas in the new version of Dropwizard, it just fails to start up. Right? It's much more apparent, it's much more in your face that you've screwed up the configuration in this new world than it was in the old world. The second thing that Dropwizard does for you is application metrics. Okay?
So in the configuration thing, can I have multiple configurations that go to the same YAML file?
Yes, the question was, can I have multiple configurations that go to the same YAML file? So this my app configuration extends the configuration-based class. The configuration-based class itself has within it your HTTP configuration, your logging configuration, and other stuff. So what you can have is you can have, instead of having just a long hanging off here, you can have another class, a whole other class hanging off of it. And that class has its own properties, it has its own validations. Which means that you can, in a single YAML file, you can have lots of different blocks that are constructed in there. So there's nothing in there to be able to say, I want this YAML file, that YAML file, and that YAML file.
No, I was thinking more of, for example, configuration with a single thing. You could have the next pieces in your application that one, and they would all get consolidated. And namespace or checker provisions against the single YAML file. So that you don't have to have everybody aware of the one and only YAML configuration file, even though they would all go into the single configuration file for all.
Right, so can we essentially decentralize the configurations within the code rather than having them all centralized into the map config? The answer with Dropwizard today is no. With Dropwizard, you actually, when you instantiate a class, or when you instantiate a Dropwizard service object, you tell it which subclass and configuration you expect to be deserialized out of the file. Dropwizard then goes deserialize the whole thing and gives it to your application. And it's up to your application then to begin disseminating the configuration down to the components that need it. So either the whole configuration or some sub-aspect of the configuration. So some things may only want the HTTP client configuration. They don't care about the rest of the config. your application would then say, I've got a handle to the hold config, I'll call get HTTP client configuration to pass that down. So there's no sort of spooky action at a distance of it, just sort of figuring out, well, there's configuration. You really have to be very explicit about telling Dropwizard, this is my configuration class, this is the root of the thing that you're going to parse out of the YAML file. Go get it for me, and then I'll take care of dependencies directly into all the things that need it.
So do you support scopes in configuration? So I want files to be different in test versus production.
So do you support scopes? The answer is no. We don't support scopes directly in the configuration. We do that at a higher level. When it comes time to build our actual application, we use Puppet for doing deploys. And so what we do is we do templated versions of the YAML file. And then we apply template values at Puppet deploy time. So.
Is there a mechanism for value handling?
There is not. It actually would not be terribly difficult to do, though. But yeah, there is one thing. Aside from spinning up the application and seeing if it crashes or not. Yeah, Dropwizard has the capability to add more configured commands to it. So the one command that it comes with is the server command, which says, I want you to spin up the server and run. There's no reason we couldn't have sort of a config verify command that gets added to it. It just says, just load the configuration and tell me if it was successful or not. That would be fairly easy to do. Cool. So moving along, metrics. We built this nice library, this one right here. This is the other big piece of open source that we have today, which is our metrics library, also built by Codahale predominantly. And a lot of people use metrics without Dropwizard. We thought it would be fairly silly to have Dropwizard and not actually bundle metrics in. It's such a great library for exposing application metrics in lots of ways. And it brings you so much. Like, it gives you a level of visibility in your application that a lot of apps simply don't have. And it's very difficult to act without the data that this would provide for us. So metrics is a very core piece of our technology stack. Yeah.
How's that different from Java Melody?
From what?
Java Melody.
I'm sorry, from what?
Yeah, Java Melody. That's a library you can slap on any WAR file, and it provides nice metrics kind of by default, and then you can extend it to collect a JDBC or any string level metrics. So why that?
So this one, mostly because we built this one ourselves, we tend to metrics a lot of things that library simply wouldn't catch. Other libraries that we use that it wouldn't be doing, right? You have your own computation that you're going to have inside that you're going to have to do metrics on. Mostly I think it's because Coda decided he wanted to build his own metrics library. He built a very, very good one. So we've always started with this one.
Just one question on the metrics there. Does JMX get used there at all? Does it interface with JMX? Does it expose anything via JMX at all?
It does. I've actually got a slide exactly on that point. Just a little bit. So the first thing that you get in metrics is you get gauges. Gauges give you sort of point-in-time reads on a given thing. In this case, the simple gauge is a gauge on queue depth for every queue. So queue depth, you want to just periodically be polled so that you can tell it the queue depth is currently 8, it's currently 9, it's currently 10 billion. This allows you to just very quickly query a thing that it has in inside so that you can return it. It doesn't have to be an integer, it can be a string, it can be anything you want really. But the gauge is going to get pulled periodically by the metric subsystem. Counters are sort of in certain cases you're going to have a thing that you don't have the ability to call size on. But you know when things get put in, you know when things get taken out, so you can use counters to increment and decrement the value. So counters are still very much a point in time. I want to know what the current value of this thing is, and I have the ability to bump it up, I have the ability to bump it down. Histograms. Histograms give you the ability to see what's the distribution of a thing. So if you, for instance, wanted to know, I have an API endpoint and it takes a batch of data, and the batch size is determined by how much data is actually fed to it. And I want to be able to go and look and periodically see what's the distribution in terms of the batch size. So when you actually receive a batch, you'll mark it. And so this particular mark says, I want to mark it as the occurrence of 1. This is Peters. Sorry, I'm looking at the wrong side. This is Peters. We'll talk about histograms, we'll come back to Peters. So in the case of histograms, what you can do is you can update it with the length. And so histograms will bucket it. When you actually see the metric, what you get from it is you get the min, you get the max, the mean, the median, the 75th, the 90th, 95th, 99th, 99.9th percentiles of a thing. This becomes really nice when you want to measure things like latencies. So you want to know things like, I have this particular API request. I want to know, in the 99% case, how fast does that thing fulfill? So we use histograms to fulfill a lot of stuff like that. Come back to meters. Meters are sort of the rate of a given thing. So I want to know how many of these things do I see per second. And so in this case, what you can do is you can mark it whenever it happens. It keeps a sliding window on the 1 minute, 5 minute, 15 minute rate of a thing. Decays over time, so you can actually see how fast you're being pulled, for instance. Timers are a combination of histogram and meter. So you want to know how often a thing is called, but you also want to know the distribution of the latency of the thing. So timers actually get used for, there's an annotation we have called the timed annotation. If you put that on one of your RESTful resources, Dropwizard will automatically time the thing so that you get not only how fast is it being called, but what's the distribution of the latency from a particular endpoint. Health checks, they're not exactly a metric, I would say, but they're part of the metrics library, which is why I lumped them into here. Health checks give you the ability to, for a particular aspect of your system, figure out whether or not it's been successful, whether or not if it's in a failing state and a non-failing state. So, in this case, what we have is you have a database connection. You want to know whether or not your database connection is healthy. I'll talk a little bit later about how this actually gets surfaced outside the application so that you can hook it up to monitoring tools. And monitoring tools can find out things like, oh, this particular host has lost its connection to the database. Perhaps we should take it out with a load balancer. Perhaps we should page an operator and have them come and kick it. Or perhaps someone should go into the database and figure out what's wrong if all of them are not able to connect to the database.
Is this extensible? I mean, does it only check to see if you can get a socket connection to the database? Can you actually specify, something to run or something like that?
So in this particular case, the fact that it's calling a database is just the example of that given. So all you do is you extend this health check subclass, implement this check method, and you can check anything you want. So as long as you've got some amount of code that can actually run and check and render a verdict on whether the thing is healthy or not, you can turn it into a health check. I've got an example further on where I'll show the health check output of one of our services running in production. So operational tools are another big thing for us. Inevitably, once you're done building your service, you're going to want to ship your service. And someone's going to actually have to operate it. Someone's going to have a pager for it. Someone's going to have to know when it's broken, what the current running state is for it. And so one of the important things for Dropwizard is making sure that that's as simple as possible. We love our operations team. We want our operations team to love us. We don't want a really terrible relationship between them. Because when they get paid for 3 o'clock in the morning and they finally come to the office the next day at noon, we don't want them looking at us like they want to murder us. So here was the question before about JMX reporting. So everything that is a metric is automatically surfaced by a JMX. So if you already have a lot of plumbing today to be able to cite the stuff out of JMX into your own systems, that stuff's going to work today with Dropwizard. You may have to make some small tweaks here and there to make sure you're picking up the right values out of it. The other nice thing is that all of these things, this is actually a screenshot that was pulled using Java Visual VM. So a lot of times what we'll do is when we're experiencing production problems, we'll fire up JVM, connect to one of our production instances, go directly to the mbeans, and then for one of these things here, like we can look at things like there's the 15-minute rate. If you double click on the 15-minute rate, it'll start giving you a rolling graph, and you can see how this is rising and falling. You can look at the latency, things like that. It starts to become very useful to be able to see at a glance what exactly is going on inside of a service. In addition to JMX reporting,
Was that a JMX reporting a function of the metrics library or a function of the library?
So it's a function of the metrics library. The metrics library has what's known as reporters. In this case, it has a JMX reporter so that all the metrics can be surfaced to JMX. There are other reporters that you can write for things like, I want to write all of my metrics out to Gangly, I want to write them out to Graphite, I want to write them to JStat. You can write reporters for anything you want. There's just a certain set of them that have come pre-canned. JMX just happens to be the one that we make one of the most uses of. Yeah.
So did you combine several here in one name, one JMX name?
So can you combine multiple inside of the JMX name? So the way that it's done right now is when you create a metric,
So it looks like that's what you did. So it looks like they have different fees there.
so what ends up happening in here is that everything gets lumped under the particular name of the metric, and the name of the metric goes under the class of the metric that you've tied it to. So it gets namespaced by the package, then by the class name, and then by the particular name of the metric. So if you have multiple metrics inside of a single class, under hello world resource, you'd see like get requests, quote requests, delete requests. And then each one of them you can drill down and see like this particular one here is a meter. And so it's,
Okay, so if you give them the same name, they'll one class wise.
yeah, get it all flash.
That's great.
So in addition to the JMX reporting, we have HTTP reporting. This is what Yammer makes most of our use of. The JMX reporting is good for when we as individuals want to go and take a look. The HTTP reporting really helps for doing automation of a lot of our metrics and our alerting. So the first one that we have is the metrics endpoint. So everything that you saw that was exposed by a JMX is also exposed as a JSON endpoint running off of the admin port. So if you remember, I showed the YAML file. It's got both an HTTP port and the admin port. The admin port is where all this stuff gets surfaced out. One nice thing about that is it runs on its own acceptor pool. So if your application happens to be completely wedged, all your acceptor sockets are taken up, all your acceptor threads are taken up, you can still get requests through to the metrics endpoint to get in and look at diagnostic information. That's a thing it didn't used to do. It used to be the case that if your application wedged hard and all the threads backed up, you couldn't actually get a request into the metrics endpoints, which made it effectively impossible to then go and look and see what was wrong with the system that was completely wedged. And so an example of that looks like this. So this is one of our staging instances of our messaging database, which is called feed. And we hit it on port 8081/metrics. And what gets dumped out here is a lot of JSON. What I've actually been able to capture here are the JMX telemetry metrics that come out of it. So in addition to the metrics that you supply as part of your application, metrics and Dropwizard are also coming with a lot of its own metrics that it's packing that it thinks that are fairly useful. So in this case, you see a lot of the memory stuff. So you can see things like how much of the heap is being used. We can see how much of the old gen is being used, 65% right now. We can take these, we can pull them out, we can start graphing them. So we can see in our ganglia over time, we can see, this is the garbage collection flow, right? Your old gen moves up, and then it drops, then it moves up, and it drops. And then you start getting worried when you see it start to plateau at 99%, it never comes back down. You're like, oh, I'm off in GC help. And you can also set alerts on these things. So we have an alerting system called Zabbix, and we tell Zabbix, if you ping this thing X times in a row and you see the old gen above 95%, it's time to start alerting somebody because it doesn't look like it's going to GC back down. It looks like it's going to put itself in a bad state. So much to come and restart it, so much to let the devs know. You might need to clean up memory, you might need to bump the heap size, and so on. This is what it looks like for us in Ganglia. So this particular metric, this is the server context handler. This is something that comes out of Dropwizard. This is the 1 minute rate of all the post requests across, I think, 45 of our machines stacked. So you can see, our weekday spikes run up to about 220 posts per second. On the weekends, it's much, much smaller. This is the level of information that we can start pulling out and start graphing and getting some meaningful information out of the runtime of our systems. I mentioned this before, metrics reporters can be added so that we can collect stuff off of their systems. If you look in the metrics GitHub project, there are modules already checked in there for Ganglia and Graphite. A few people have been working on some other modules on their own, but those are the two that are fairly well supported right now. We talked about health checks. Health checks can also be hit off the admin port at /health check. And so this is what the health check starts to look like. This is one of our other services, Syncy. This does Active Directory sync. And it has 2 health checks that it supplies on its own. One is called Hornet we have a Hornet queue that stores all the jobs that we want to run. Everything's okay there. We have a Zookeeper client health check that makes sure that we can actually connect the Zookeeper. We can create a node, we can delete the node. And the last one, Deadlocks. This is actually a health check that comes from Dropwizard. And so the Deadlocks health check is nice because if you have a situation where you're doing highly concurrent processing, Dropwizard will periodically do a thread dump. It'll look at the threads and it'll see, is there a situation where I have a thread A waiting on thread B and a thread B waiting on thread A? If so, I'm going to throw my hands up and let people know that there appears to be a deadlock in the system. Super handy to be able to have that just start popping out of health checks, rather than just start to wonder why all of a sudden your HTTP server is no longer accepting connections. Thread dumps. This is another super useful debugging tool that we have. One of the things that we've done with thread dumps, it actually came from, we had a service that we wanted to do this and eventually got ported into Dropwizard, was having the ability to have a servlet filter that on input, it would essentially rename the thread so that you could see the HTTP method and the HTTP URL being called during the entirety of the call. This has now found its way to Dropwizard, which means that you could actually hit the /threads endpoint and you can see at any one given time which URLs are currently in flight. So if you see that you're backing up a lot of requests inside of your web server, you want to know, oh my God, what the heck's going on, you can get a thread down, you can pull out all the URLs from it, and you can see, wow, this one particular endpoint appears to have a high volume of contention. Maybe I need to put some work into there. And so this is an example output from that. So you can see, here's the main ID thread, ID1 thread, right? This is your main, I guess, reference handlers, finalizers. Somewhere way down here, you've got your QTP threads, which are the actual Jetty threads handling requests. Just couldn't get it all fit on one page. Last, there's a ping. Ping doesn't do anything particularly interesting. It returns 200 in the text and ping com. Mostly, it's a very quick smoke check of, can I reach the server? Will the server accept the connection? Will the server process the request and send back a response? This will finish very fast. This is nice for doing things like if you want a quick load balancer health check, so the load balancer can know when to take your service out of rotation. We use this a lot for that.
Does this use the same acceptor pool as the rest of the application?
Yes.
So it's distinct from metrics or values.
Correct.
So you just said that admin port is used to separate the kind of client's traffic from the admin traffic. So the ping, does it say anything about health of the client pool?
The HTTP port? No, you're right, it doesn't. I'm sorry, I was wrong. This is pulling from the admin pool. So this is not actually checking the main HTTP application pool. Thank you. And so that's what it looks like. It's very simple, returns very quickly, just says POM. Yes, I'm reachable. Logging. We have a very simple wrapper around SLF4J. The reason there's a small wrapper around it is SLF4J is a nice API from the standpoint of it has a lot of nice features, but from the standpoint of actually using it, it has this really weird thing where you give it a string and you can give it an object, or you can give it a string and two objects, or you can give it a string and an array of objects. Sort of ignore the fact that you can start passing variable length arguments. And so what the logging class here is predominantly doing is just adding the var option to SLF4J. So you keep all the nice string formatting from it, but you also get the var implementation for it. In addition to application logging, it also supports request logging. Both application logging and request logging support logging to the console, logging to files, logging to syslog. So there's fairly nice facilities for being able to do logging there. It does rotation and compression. Compression is actually new, I think, in Dropwizard 0.5. Prior to that, we had to actually ratchet down the number of files that we're actually keeping. It had rotation, it did not have compression. Some of our services get hit fairly frequently. Next thing you know, we're filling up our log with gigabytes upon gigabytes of log files. So log compression has been a big win for us to be able to crank that down and actually keep more than one log file in the system. The other thing that comes in 05 or 05.1 is Dropwizard's own request logging facility replacing Jetty's request logging facility. I don't know if anyone here actually uses Jetty's request logging facility, but it became very clear to us that mathematics was not the Jetty team's strong suit. If you told Jetty that you only wanted to retain one log file, there was a strong probability it was going to actually retain two. And this was because of some rounding errors they had in their math, which made it virtually impossible to say, I only want to keep this one file. You're almost always going to have two files on the machine. It became a bit of a sore spot with our operations team. Them constantly asking us, why are you keeping so many log files? We tell them we're only keeping one, we promise, but Jetty's bad at math. So we've been going through it fairly ruthlessly, starting to update some of the projects to the newer versions of Dropwizard, just so that we can take advantage of this, which is sad. Moving on, JSON is another big thing that Dropwizard has support for. It provides support through the Unbeatable Jackson library. We're very fortunate that the author of the library is actually sitting in the back of the room today. There are plenty of other JSON libraries, but don't be fooled by the pretenders. They are not good libraries. Jackson is the one true library. It's super reliable, it's crazy fast, it's getting better all the time, it gets super amounts of attention. It's integrated very well to Dropwizard. Just HTTP, I mentioned before, we use Jetty for everything. Jetty is very nice. It's got a good embedding story, which a lot of the other Java web servers don't have. And embedding is very important to us because of the way that we deploy, which we'll talk about a little bit later. The other thing is that it doesn't have the track record of some of the other Java web servers for issues with bugs, issues with security, issues with performance. So we stick with J for everything Dropwizard. With Dropwizard, that's non-negotiable. You cannot use any other web server with Dropwizard. We use JaxRS, aka JSR 3.11, for all of our RESTful needs. Jersey is the implementation we use under the hood. It's the reference implementation for the JSR. It is one of the finest things to ever come out of any JSR. It's just such a nice, such a clean API. And the crazy thing is, like the JSR spec, it's actually readable. It's kind of crazy. I've never actually encountered a JSR spec that I could actually read and not fall asleep and not just forget anything with it. And it's very easy to consume. There's a lot of good stuff in there that I won't be covering. If you ever get a chance, I encourage you to go read it and see some of the nice things that are available in JaxRS that, like I said, that I won't be covering. If you have not seen JaxRS, this is a very simple RESTful web service. It listens on /users/some ID. That's the path annotation at the top. JaxRS is very annotation driven, as opposed to the servlet API, which is very class driven. And so one of the very nice things about using JaxRS is that this just looks like a class to the compiler. It doesn't, if you want to test this thing, you're not sitting there trying to mock servlet context. You're not mocking HTTP servlet requests. You're not mocking HTTP servlet responses. You instantiate one of these things, you give it any of its dependencies that it needs, and then you just start calling methods on it. And you take the response, you take the object that comes back out of it, and you verify that you got what you need. It's very, very easy to test these things. That's one of the things that we love about it. It's also, like I said, it's very annotation driven. It's very easy to sort of see where all the pieces of this come from. It's very easy to see that you have a get method which will return you a user if you supply an ID. There's a put operation that you can write the user to a given ID. Jackson steps in here again, giving you serialization and deserialization of all the objects, so that you don't actually know what's happening. But when you call put with a JSON that looks like a user, Jersey dispatches to Jackson. Jackson turns the JSON into a user object, and then Jersey under the hood begins routing that particular those particular parameters into your object. It's like magic; it just happens. So all of this is very interesting. This is all stuff that you can mostly find on the Dropwizard documentation site. So I wanted to spend a little bit of time talking about how exactly Yammer uses Dropwizard. So I think this is, out of all the companies, out of all the individuals who use Dropwizard, nobody uses it as much as we do. And so hopefully people can learn a little bit from what we've learned over almost 2 years of using Dropwizard now. We build lots of small services. We have about 16 services and counting now that are all running on Dropwizard. This is a big departure from other companies I've worked at, where they'll instead build these really big monolithic services that do everything. At Dropwizard, or Yammer, we're not going to at Yammer, we use Dropwizard to build a lot of these very small services that do, they do very tiny things. They don't have to do everything. They have to do one thing really, really well. And so it ranges from things like we have a messaging database all the way up to the push interface for being able to push notifications out to browsers. We have analytics engines all the way down to search engines. And so we build all these things on top of Dropwizard, but we build them very, very small. They're very small code bases. They range from maybe 1,000 to 4,000 lines of code each. The fact that they're so small means that we can build them very easily, we can test them very easily, we can deploy them very easily, they're easy to monitor, they're easy to fix when something goes wrong. The fact that we keep a lot of these bite-sized pieces around just makes it so much easier on us to deal with, especially the fact that it's 16 services for a team of only 8 people. So, Maven is our friend. I'm not sure how popular Maven is here. We were just talking about Maven. We've used Ant, we've used SVT, we've used Maven. We used to do a lot of Scala. We got the hell off of that. SVT was no small part of that. The Scala compiler was another big part of that. We had Mark Nedersky in our office about 2 weeks after we almost publicly proclaimed that we were moving off of Scala, and gave him a litany of reasons why we're moving off. Maven's got a fairly same story. It works well with continuous integration environments. It works well with IDEs. It's very difficult to find faults with it when you compare it to a lot of the other tools that are available today. In our case, we stick the code in GitHub. We actually use the public GitHub with a lot of private repos. So all 16 of our services are out in GitHub. GitHub's nice because it also plays really nicely with continuous integration. So we can point our internal Jenkins instance at the external GitHub and tell it, I've got a project over here, I want you to build it anytime something changes. It just works. It's also nice for working on distributed teams. So work separate from one another, merge back stuff later on, deal with pull requests, that kind of thing. Yeah.
Sorry, I have a question about the services you were talking about earlier.
Yeah.
Are they all synchronous, or do you have any async services at all?
Do we have any async services? So we have some async services. Most of our stuff is done synchronously. The asynchronous stuff is mostly done using RabbitMQ. So there's a couple of layers where our Rails ends up interacting with the Java, where the Rails can't sit around and wait for some of the heavy processing to be done in the backend. It drops something into RabbitMQ and returns to the user immediately. Some of the Rails picks it up off of RabbitMQ and then makes a call to the HTTP backends. There's a little bit of async processing in some of the Java systems where we'll sort of do the immediate bit of work now and put some other work later on to be kicked off by a backend process. And those are places where we kick off either executors or dedicated threads for things. So a little bit of async, not too much. Yeah.
So I'm not familiar with kind of services you have. Could you talk about what they are, who uses them, how they use them, that kind of stuff? Or...
Yeah, so Yammer's backend, like I said, is built up about 16 services. We have services for real-time push notifications. So when someone actually sends a message, it gets delivered into the messaging database, which is another service. The messaging database issues a notification to the real-time service saying, I have delivered the following message to the following feeds. The real-time system receives that message and says, are there any connected browsers who are interested in these feeds? If so, send them notifications that a message has been delivered. Suddenly the browser goes, ding, you've got new messages. So we have real-time, we have a messaging database. The search system is actually comprised of 4 separate services. We have the leading edge service, which stores all the change sets. So every change that's ever happened in Yammer is indexed by the system in transaction order. There's a system that sits behind it, which actually does all the search indexing. So all it's doing is constantly traversing the sets of changes. So it has the ability to go to the first service and say, give me all the changes since change 19. Gets a log of 1,000 changes. Okay, give me all the changes since change 1,019. Gets another log of 1,000. Chunks those into a bunch of Lucene indexes, and then it provides a replication endpoint for the back 2 services, which are the full text search and autocomplete search, which they replicate Lucene indexes to their local disk, load them into memory, and begin serving searches out of them. So there's 4 services there. We have an Active Directory sync service. So it takes payloads from Microsoft Active Directory for user provisioning and deprovisioning. So your IT group has 10 new people they're onboarding. They go turn them on in Active Directory. Active Directory sends those accounts to Yammer. Yammer turns on those accounts so the users don't have to go create an account and come there. When the user gets fired, Active Directory fires off an event, comes back to Yammer. Yammer knows deprovision this account so they can't come in and take all these company secrets out of them. We have a data export service. So for companies that need to do e-compliance, if they need to actually siphon all their message data out to a third-party service so that if they ever had a lawsuit, the lawyers have a copy of the data that they know they can get to. They use data export for that. We have Whoville, which is our presence service. So is this user online now or are they offline now? That gets used in our new chat feature. A lot of other services.
So I would take a source code for that service and then I run it, or you're running it?
So Yammer is all run in the cloud, so nobody runs on-premise Yammer. So only Yammer runs Yammer. If that makes sense.
Quick question on the private stuff.
Extra.
Do you have Dropwizard back services that are just Rabbit, not HTTP, or is it you just happen to have a Rabbit component that calls out that database?
So none of our Dropwizards actively talk to Rabbit. Rabbit is there purely to deal with the deficiency in Rails and being able to cope with long-running tasks. So the Rails front end receive a request, they know it's going to take a while. They'll put it into Rabbit so that they're not tying up the main Rails threads to do things. Dedicated Rails workers in the back end will then pull it off. Dedicated Rails workers that were okay with being tied up for a little while they go and do the heavy lifting off to call other things.
Rabbit's not part of the Dropwizard.
Rabbit's not part of Dropwizard. You can make it part of Dropwizard. Once upon a time, we had a Dropwizard service talking to Rabbit. It was terrible. We're not super big fans of Rabbit. We're eager to involve Rabbit. Rabbit doesn't have a good multi-DC story, so we're certain that when we move data centers, Rabbit will not be following us.
You could have a really nice story about a rabbit and a wizard and a hat.
Put the rabbit hat in it. Yeah.
How do you do routing? Like how do you...
So the way that we do routing, we take all of our Dropwizard services, we put them behind a load balancer. So all of our services, they're either stateless or they're routing capable themselves. So the load balancers are completely done. They'll just pick one of the boxes at random and route the request to. For the stateless services, they'll receive the request, they'll do the work, they'll return a response. The messaging database that we have is actually, it's very stateful. It's actually a partition database, 256 partitions running 3-way replication across 45 machines. And so what will happen is the Rails machine will send a request to the load balancer will pick one of the messaging database machines. The database machine will then say, this is a request for partition 15. I don't have 15 locally, so I'm going to look up in the table who are the members of 15, and I'll forward the request to one of them. It actually proxies it. Sends a request to that host. That host says, okay, I'm a member of 15, but this is a write and I'm not the master, so I'll hop it one more time to the master. Master receives it, says, it's a write, it's for 15, I'm the master of 15, therefore I'll handle the request, and then pops it back.
There's no like this hopefully or something.
That's right.
If I want to be clients of one of the services, I need to know name.
Yeah, so if you want to be a client of the services, what you need to know right now is you need to know the host name of the VIP of the load balancer, essentially. Other than that, we hide everything else. You need to know the URL, you need to know the host name, you need to know the URL you want it to. So you can click GitHub, shape your jars. This is one of the most important things I think that we do for deployment is we don't deploy thin jars, we deploy fat jars. So all of your dependencies in Maven that you have declared, all the sub-dependencies that they then bring with them, during our build step, we use the Maven build plugin to actually grab all those jars, package them into our own jar. The Maven shape plugin has some really nice things for dealing with conflict resolution, making sure that resources, things that are in your meta-INF directories for each of these, they don't collide, they get copied in the appropriate ways, and they still load correctly. What it means is at the end of the build, we end up with a single jar that is our application. And so when we want to deploy, the only thing we have to deploy is that one jar. We don't have to deploy that jar and the 150 dependent jars that we have. When we actually want to invoke the service, we don't have to have this long Java execution where it's java-cp, this jar, that jar, that jar, that jar, that jar, and then my jar. Right? We just say java-jar, my.jar, server, foo.yaml. So it keeps things very simple. Yeah.
Just curious, you put all 15 of your services in your
No. No, every service builds independently into its own jar, and then we deploy them separately. I think I've got a little bit of stuff on how we deploy this. So, get yourself some continuous integration set.
Sorry. Yeah. So one thing that our library code does is that we have different jars for the library codes, and each jar can have like default properties which get picked up on the library, so we can have multiple ones. Would it be a problem with something like shades? Probably. One would be basically.
Possibly.
Yeah.
Possibly. Our shade use is mostly around making sure that there's no collision in the meta-INF files. We don't have any particularly exotic use of dependencies, so I have to test it out and give it a try. About as exotic as we get is making sure, deciding whether we're going to use snapshot or release versions of jars. It's worth trying. We use a lot of continuous integration at Yammer. Everything that we build, or everything that we code gets pushed into GitHub. Jenkins, like I mentioned earlier, is watching GitHub for changes. So we have, in Jenkins, we have one job per service. So each service, as we check in a file that gets built by Jenkins, Jenkins builds a snapshot version of it and actually pushes it to an internal Maven repository. So all of our built artifacts are in a Maven repository, whether it be a snapshot or whether they're release. We also use Jenkins with the Maven release plugin to be able to correctly go in and say, I want to now peel off a release of this. I want to bump the version number in the source repository system. And so we're able to do all of our builds entirely out of Jenkins, pretty much automated. The only thing that we have to go in and do manually is decide when we want to cut an official release version of it. This is a big break for us because it means that we don't have someone who just sits there like, okay, so who's going to make the build today? Oh, you made the build, did it fail that time? Well, you built it on your machine with your weird dependencies. Everything is built on one box, one environment, and it's constantly being built. All the tests are being run, code coverage is being performed. It's just nice to have it constantly running in the background to pop out a warning if something goes wrong. I highly recommend it. Bring yourself a startup script. We run our stuff out of Upstart because we run on Ubuntu. Upstart is kind of a nice wrapper for doing stuff in init.d scripts. Having an Upstart or an init.d script, startup scripts, they're very beneficial for making sure that operations can very easily get onto the box, stop your service, start your service, restart your service, reason about whether or not the service is actually running. It also means that if the box goes down due to a power outage in the DC and it comes back up, the service comes back up, it means that if you burn your application into an Amazon AMI and you fire up a new instance of it, the application automatically comes up. A lot of benefits to having a storage space for it. Have a good deploy story, so this gets back to sort of our deploys. We let Jenkins build the jar file for our application. What we also do is we have a tool that we built in-house called Deploymacy, which is our deploy tool. And what Deploymacy will do is you go into Deploymacy and tell it, I want to now build a package that I want to deploy. Deploymacy will go to the configuration repo and get all the configuration files for the application. It'll go to Maven, or to Nexus. Nexus is our Maven repository. It'll go there and grab the jar, it'll bring that down. It'll then create a Puppet package out of the combined jar file and configuration. It'll take that combined package and put that back into our Maven repository. At that point, all the deploy artifacts are in Maven. We can then go in and do a deploy where we click a button and say, okay, this is the messaging database. I want to deploy the latest version of the config, the latest version of the application to all my machines. And so we can actually do a 45 machine deploy in about 5 minutes. We probably go faster if we're running those in parallel, but in this case it's a messaging database. We don't like to do it in parallel because we've got to make sure we keep forums running and whatnot. But having a good deploy story means we get to iterate on things very rapidly. It means that we're never afraid to do a deploy. It means that if something breaks, we can get a code change and have it pushed out in under 5 minutes.
Which sort of leads into the question of what's your service versioning story?
Service versioning story. So do you mean the jar versioning? Do you mean the API versioning? Do you mean everything? So we've been very fortunate that we haven't had to really break API versioning much yet, right? The services are under 2 years old. We haven't had to do a lot of backwards compatible breaking stuff. We've been able to extend the existing JSON. We've been able to add new API endpoints without breaking old API endpoints. So we haven't sort of reached the maturity level where we start running into the, well, crap, we want to roll a V2 of the API. We've got to keep the V1 around long enough to transition into the V2. So we haven't really encountered it yet. There's nothing in Dropwizard specifically that helps you with this. Mostly it's going to come down to sound API design principle. It's going to come down to things like when you actually redesign the code to support the new version of the API, whether or not you want to be able to build it in such a way that it can also support the old version of the API long enough to transition the clients off of it. There's really nothing in Dropwizard to help you. There's nothing in JAX to help you. It's just, it comes down to you to do it.
So the related question is, how are you handling the rolling update problem on GitHub?
The rolling update of our services.
Yes, it is behind a random load balancer.
Sure.
Or you're not concerned about one minute and one version of JSON that you can.
So in a case, so we've never broken backwards compatibility, which means that even if the clients hit a version running the old version and a version running the new version, they have the same subset of JSON, right? So if you deploy the changes first to the service and then you deploy the changes to the client, you never run into a situation where the client is expecting something of JSON that's not there.
So your clients are required to deliver the JSON subsets.
Yes. Yeah, the clients aren't looking at it saying, well, this has got a food property. It's not supposed to have a food property. It's saying, well, there's a food property. I don't know what that is, so I'm just going to ignore it. The clients are very liberal about making sure that if they see something they don't understand, just ignore it. This isn't the world of XML and DTDs where it's going to suddenly freak out if it sees something it doesn't understand. This isn't the weird world of SOAP where you need to append everything with XSD any in order to make sure that old clients will ignore new stuff. Fortunately, JSON is just not that strict in most cases.
Well, you have to imitate your Java class.
Yeah.
To ignore what you said.
So just out of curiosity, is the interface from the web tier to the services layer, is it all just REST?
Yes.
So you've completely abstracted away. It's always just the network call.
It's always HTTP, it's always REST. Yeah.
And no issues with performance or,
So we have a spectrum of service latencies. If you look at the messaging database, it probably has some of our highest latencies for what we call large fan-out deliveries. If you're thinking about a message, say you're on the Yammer network that has 500,000 users on it, and you want to send a message, we materialize all of our message feeds, which means we don't store just a single message. We write that message to every one of those users' feeds. So we have some high fan deliveries there. Sometimes a write may take up to a minute to do all those writes. We have certain networks that are very, very large. Microsoft's network is actually now getting to be fairly large. They haven't quite reached high engagement yet, so they're not as big a problem as some other networks. But Microsoft over time, I think, is going to become one of our heaviest networks. We have other services where the latency profile is tiny, because that particular service actually has to be in the main line of one of our Rails requests. And Rails processes are very heavy, they're very expensive, you don't want to hold them up for too long because you don't have very many of them to begin with. And so we've got some Dropwizard services whose P95, their 95th percentile response latency is something on the order of about 80 microseconds. So we can very easily do sub-millisecond latencies with the Dropwizard service. And this is on a service that's actually doing reads out of BB on the back end. So it's not just exclusively doing things out of memory, it may potentially be hitting disk for some of this stuff. Dropwizard performance really has never been a concern for us. It's always been a service to build on.
So is the profile in your application mostly a large number of requests but small amounts of data, or is it a large number of requests, large data, or?
I would say our requests skew towards more small requests than large requests, but we do, we have out on sort of the 5% to 2% tail where we start seeing some very, very large requests, because like I said, some of these large networks where suddenly you get an activity that touches 500,000 feeds for us.
Or say I've got a video or something that I want to send out to a whole bunch of people or something like that.
So videos are handled separately for us. We don't actually handle videos in-house. So we end up dumping a lot of that off to S3 today. So a lot of that goes off to S3, and we just store locally the metadata for the files. So because the metadata is very small, we don't have to deal with these large streams. We do have our data export service. Sometimes the data exports can end up being multiple megabytes or multiple gigabytes of data. And what we do there is Jersey and JaxRS, they have this facility called streaming output. And what this allows us to do is not actually hold the entire response in memory. We can make a streaming call to some other service, and as that streaming out begins streaming bits out, so we're actually only holding a very small subset of memory. So the big fan things don't always hurt us that badly, in terms of memory profile at least. Over time, Dropwizard has kind of grown some appendages. So what I've mostly been talking about is what's known as Dropwizard Core. Dropwizard Core is concerned about the things that I mentioned before: metrics, logging, HTTP, JSON, operations, and so on. Over time, some of our services have sort of had other needs, and eventually those needs have kind of crystallized themselves into modules, or what we call bundles in Dropwizard. And so these are a number of bundles that are actually available through the Dropwizard service as separate native dependencies. The first one is Dropwizard Client. This is for if your service itself needs to be an HTTP client of another service, you can use Dropwizard Client and say, I want to construct a new client. I want you to manage the thread pool for all of my clients. So I want you to manage wiring up all the serialization and deserialization for JSON. So I want you to wire up Jackson into my client so this all works properly. And so you just drop this in, use the factory to create your new connection factory. You hand that off to one of your resources, and your resources at any point then can say, I want an HTTP client, or I want a Jersey client. The difference being HTTP client is very low level. It says, I want to call this GET and just give you that input stream. Whereas Jersey client is, I want to call it GET and I want you to turn it into one of my food classes. A particular class I want you to do all the deserialization for me. Dropwizard DB, based on Brian McAllister, sorry.
Sorry, on the last slide.
Yeah.
Are you giving out then the Jackson that runs through JSON?
Are we giving out the Jackson?
The objects generating JSON using Jackson. So is that available so that I can use your objects in the Jersey client?
Yes. Dropwizard DB, based on Brian McAllister's very nice JDBI library. Sort of think of JDBI as a nicer interface than JDBC, but not carrying all the baggage of full ORM layers. So if you don't want, say, full Hibernate, but you want something that's a bit more convenient to use something like JDBC, JDBI sort of fits this really nice layer between. Dropwizard Authentication, at a certain point, most of our services get.
Again, the question, why that whole DBI versus MyBatis?
This one was personal preference. Coda decided he wanted to build something using JDBI, and when he got done with it, he decided he was going to make that module part of Dropwizard that people could optionally use if they wanted. So, just preference, we decided to use that. There's no requirement that you use Dropwizard DB. If you want to use something else, you're free to use something else. A number of people I've seen using Hibernate and whatnot with Dropwizard. So. Dropwizard Authentication. Most of Yammer's backend services are internal only, so we haven't actually needed authentication for them. Some of our internal administrative tools need to hook up to LDAP in order to make sure that we're only allowing employee access to them and specific employee access to them. And eventually we started adding OAuth for some of our internal services so that the front user-facing services could then proxy a call to our back internal services, but still supply an OAuth to it to make sure that we're still authenticating things correctly. And so what Dropwizard Authentication gives you is the ability to say, I want to protect a resource with an authentication context. And so by example, what you have here is one of the parameters in the JAX-RS object is annotated with this @auth annotation. And in this particular case, what happens is you wire it very early on. You say this is my authentication provider. An authentication provider takes some aspect of the HTTP request and it returns token objects. So whenever there is a resource that wants token authenticated objects, you should dispatch this inside of Jersey, goes through, determines whether or not they can actually get one of these token objects. If required is false, it's turned off, then it will actually go ahead and give it. And you can do nice things like, if I actually have a token, then generate a response that is based on a given user. If I don't have one, give me a response that's based on some guest user, because I don't have an authenticated user at the moment. Dropwizard views, you can build either full-blown application UIs or just build admin interfaces. We've mostly only used it for building admin interfaces. We haven't actually tried building full-blown applications with it at this point. It has free marker and mustache markup capabilities. Basically what happens is you can take the exact same RESTful service endpoints that you have today. You can add another produces annotation to it that says, not only do I produce JSON, but I can also produce HTML. And if you have the Dropwizard view bundle attached to your Dropwizard environment, and the client in the accept header says it wants HTML back, Dropwizard will then take say the user object that gets returned, it'll go find the corresponding template for it, and it'll try and merge the two and send HTML back to the client. And the really nice thing about this is you get web services that work both as JSON output and HTML output. You get it for free. Dropwizard Scala. The original Dropwizard was written entirely in Scala. One day we decided we really didn't like Scala, so Coda in Rampage when we rewrote it in Java, which left some people in a lurch, and so he went back and sort of rewrote the Scala bits as sort of an add-on. So if you still are so inclined to use Scala, you can still call Dropwizard, but it's basically a veneer on top of the Java Dropwizard. And lastly, we have Dropwizard testing. It's mostly some glue help for inside of your test for testing things like I want to verify that my JSON representations are coming out the way that I want them to. So I'm going to give you an instance of one of my classes that will be returned as part of my resource, and I'm going to give you a handle to some JSON file off of my resources directory. I want you to verify that the JSON produced by this object is what I expect. So you get these nice fixtures. Just say, generate this to JSON, compare it to that file, rather than to the read of the JSON, generate the JSON, compare it to. So it's just a nice little facility for doing that. And then there's also some help around doing testing of resources. So I blew through a lot of this fairly quickly. Fortunately, Coda has gone to the trouble of writing a tremendous amount of documentation. This is stuff that he wrote probably in the last 6 to 9 months, I think. And the day that he wrote this was, I think, the day that Dropwizard development really got serious. A lot more people started taking it more seriously because it wasn't just this open source project in some guy's GitHub repo. There's actual documentation to it. It's got a fairly good quick start for getting up and running with it. A lot of good code samples. And there's an example application to go along with it as well, which is tucked away inside of the Dropwizard repo. So, like I said, I haven't given the Dropwizard talk before. I wanted to make sure that we left some time for questions to make sure we filled in any gaps and talked about some areas that maybe I didn't quite get into. Yeah.
What are some of the complaints you received? Or what are some of your 8 points of Dropwizard? Things that you want to improve?
My main pain points with Dropwizard these days, I don't have a lot of complaints these days. We've fixed a lot of them. Logging was a big pain point for us initially, mostly because it generated a lot of pages. Then we got a lot of the request logging stuff fixed. We got log compression fixed. In terms of Dropwizard, there's not a lot that you can complain about with Dropwizard, mostly from the standpoint of it's mostly glue, right? Dropwizard doesn't actually implement a lot of the stuff. Mostly what it's doing is taking a lot of off-the-shelf libraries and coordinating them to all work together. So if I had complaints of a lot of the Dropwizard stuff, it would mostly be to complain about some of those libraries.
So related, I know you do JSON, but what if I wanted to do stream, like respond now to JSON, but with bytes, like an image.
Yeah, so if you use streaming, so you can either, because of JAX-RS, you can do everything in JAX-RS. So you can return an input stream, for instance, and JAX-RS knows how to serialize an input stream. You could return a streaming output and sort of work the same way, only instead of getting an output stream, you actually have the opportunity to write stuff to it. So instead of getting an input stream that it'll read from, you get an output stream that you can write to. So, you know, if you have a blocking service that you're getting stuff from, you can go and write from that and read back down to it. Read from that, write back down to it. Yeah.
Maybe I summarize the WSDL way of doing services. So in this case, we actually use it's like code is the documentation, but I'm going to try to distribute it as well. What do you actually do for documentation?
So for service documentation, it becomes fairly manual at this point. So a lot of times when we spin up a project that ends up involving a new service or additions to an existing service, someone will go into Google Docs and they'll just start writing, these are the new API endpoints. There's a project called Swagger, and they have a bunch of stuff they use for generating documentation. I hate it so much. One of the problems with Swagger is that Swagger requires you to subclass from their classes, and it requires you to use their annotations, whereas there's sufficient information purely in the Java docs to be able to generate this. So one of the things that I've been working on in my limited spare time is the project that generates Swagger service definitions, but using Java doc, which means that all you have to do is go and build your class, fill in all your Java doc comments, and it'll generate the exact same output, but you don't need to subclass any other classes, you don't need to use any other annotations. It gets built at build time, not at runtime. And at that point, all you need to do is bolt in Swagger's standalone UI, point it at the service descriptor, and it can do exactly what the Java and Scala versions of Swagger can actually do, just without any of the extra baggage. It's not super full featured yet. There's been a couple of contributions helping out with it, but it's in the Dropwizard, it's in my GitHub project if anyone wants to know about it.
What's the name of the project?
So if you go to github.com/BrianKennedy, it's one of the first ones in there. It's like Swagger Dropwizard Swagger or something.
Well, the question of documentation, I thought that you actually publish your beans that are getting turned into JSON.
We do.
You do?
We do.
Well, I thought you said that's what's part of the documenting. You got the Jersey client.
Not so much. No. Sorry. That is something we will get if we ever get the Dropwizard Swagger stuff finished up, is that will start showing up in the documentation there where you're not just documenting the endpoints, but you're also documenting the entity formats for the inbound and the outbound objects. So we'll get documentation for free there once we get that stuff wrapped up. But there's nothing in terms of, there's no WSDL, there's no DTD, there's no JSON schema.
Or you just gave the Java class to that.
Well, sure. I mean, all of our services are inside the company, and everyone has access to GitHub. If they want, they can just go grab them.
Because some native plugin for it, available if you wanted to generate it. I haven't really been able to get it to work very well.
So the reason I bring this up is that network companies work from and generated a client, a Java client, that used Jersey to talk to the Jersey backend. And I just took all the beans that were being Jackson.
One of the things that we started doing, we haven't been super consistent about it, we've been starting to do this, is when we build a service, we actually build it as a Maven multi-module project. So that there's one module for the service, and there's one module for the API. And so the beans actually get stuck in there. Which means in theory what you can do is you can actually write a client that's using the HTTP client, but depends on the API package so that you have the beans local. It's something we've been starting to play around with. We haven't used it extensively.
3 jars.
Yeah.
One was the bean, one was the server.
Yeah.
Yeah.
We started playing around a little bit with that. We'd like to do more. We just haven't gotten all the way down the path. Yeah.
So what do you use for your annotation processing? And I think it's dependency injection and libraries. Is there one that you guys use?
It's inside of Dropwizard. I don't actually know what all he's using for it. I think some of it is coming natively from Jersey itself.
You don't have your own annotation?
Excuse me.
You don't have your own annotation source?
We have one of our own annotations, which is the authentication one. And I believe for that one, Coda might be using a bytecode manipulation library. I'm not sure.
So you don't use your juice or spring?
We started out initially using Juice, and for a time we liked it, and then as the services kept getting more and more involved, more spooky action at a distance. It was kind of like, where did that class just come from? It made it very difficult to sort of see where your dependencies were going. And we found that the minute we ripped juice out and we started actually just passing the objects around manually, it forced us to think design a little bit, and it really wasn't that big of a burden to begin with.
So you don't use a screen right?
There were a lot of people asking for Spring support in Dropwizard. Coda will never add Spring support in Dropwizard. Coda hates Spring with passion. But there are a number of very motivated individuals who want Spring in Dropwizard, and so they've been building a lot of modules themselves. So the community will find a way to put Spring with Dropwizard, but it just will not come by way of Coda.
Who's Coda?
Coda is Coda Hale. He's our infrastructure architect. You can find him on Twitter as Coda. He's frequently on Twitter, either being pinged by people who think that he's the person who writes the Panics software, or the HTML editor, or he's on there flaming the creator of Redis. He's a very strong personality. He's a very fun individual to work with, but he can be a little prickly. If you ever get onto the Dropwizard mailing list and you ask him for something and he says no, do not take it personally. Okay.
Well, first of all, that's very good. Looks like there's a lot of features in Dropwizard. How would you compare it to the Play framework?
How would I compare it to the Play framework? It's been a little while since I played with the Play framework. Probably about 2 years, probably since just before I started there at Yammer. Play at the time seemed like it was much more geared towards front-end application development, whereas Dropwizard was built almost entirely from the start as something for building RESTful services. And sort of the UI has come as an afterthought of, well, someone decided they wanted a simple admin interface to manage their service. So, okay, fine, I'll give you a free one. So from that standpoint, it's definitely not as front-end centric as something like Play is. It also doesn't have sort of, at least when I was using it, Play had sort of more of the Rails model of having scripts to generate things. Dropwizard definitely has not got scripts to generate things. The closest thing we have to scripts to generate things is someone built a Dropwizard Maven archetype for rapidly generating a skeleton for Dropwizard services. So, if you want more front-end stuff, Dropwizard probably is not ready for you for prime time. Yes.
So you, for example, certainly have a Play application that talks to Dropwizard services on the back end.
You could, definitely.
That would be the difference.
Yeah.
I do have a follow-up question, though. So you talked about how in your infrastructure your requests come in and it's looking for a specific partition or something like that, gets redirected to something else, and then it gets redirected to something else. So that's kind of the beginnings of something like a lookup service or a locator in some sort of distributed system. Gene used to have something like that. Have you guys thought about implementing something like that? Or?
Yeah, we've talked about, so we actually, a lot of that is extracted into its own library that runs on top of Dropwizard. We call it Party. It's how we do distributed Berkeley DB. It has its own notion of a routing layer. It has its own notion of how it does partition lookups. We've talked at different points about open sourcing all or parts of it. The problem right now is it's all very tied together. We haven't taken the time to break it and start breaking it apart into separate concerns like this is how you do routing, this is how you do Berkeley DB. And so it would take a little bit of work to start teasing some of that apart. But yeah, I think at some point it would be helpful for Dropwizard or someone else building separate Dropwizard to start implementing routing logic. One of the things that we found when building the Berkeley DB stuff, it's very difficult to do dynamic management of the routing table. I spent probably about a month trying to get it all right after trying various approaches with it. We used Berkeley DB's built-in replication groups that fell apart very rapidly. We tried using JGroups, that was just a complete disaster. We used Zookeeper, that was probably even a bigger disaster. And eventually it came down to let's just use static files. Because we knew we could make static files work, and ultimately we got the service deployed, we ran it, and we haven't regretted it enough to go back and address that. But it's one of those things that's very difficult to get right, to have forum-based consensus around the current state of a cluster. It's very nice to have that as a thing that you can drop in and know that it's going to work for you. If anyone of you ever runs across one of those, please let me know.
Yeah, there is one. Eureka. Yeah. Have you heard about that?
I don't know.
No, that's gosh, I'm blanking. Our DVD and streaming provider company.
Netflix?
Netflix, just open source that.
Actually, it's working Netflix. So,
How do you spell it?
Eureka.
Eureka, yeah, so Eureka
Eureka!
was, yeah. So Eureka was originally part of another service. It was, when I was there, they called it Discovery. And it was all based around heartbeats. It's very heavyweight to run. Like you have to actually run a full-blown service just to do where is this thing running, as opposed to what we had been looking for, which is more of a lightweight peer-to-peer, or even just based on something like Zookeeper. Eureka's worth a try.
Yeah, but that's looks like it's heavy, yes, but it takes care of the replication and all that. But in the end, client talks peer-to-peer to the server, right? At least that's the promise.
Having worked with the early versions of Eureka, I'm a little bit skeptical about its use for this, but I would love to go back and revisit it.
For the metrics library, I think you said that health checks were part of that. Have you guys thought about including things like class detection and extra aggregated service on top of that, similar to what you put for leaders with 99%? Just services like
Not really. Health checks kind of got to a point where they were sufficient that we haven't spent any more time on them. It would be interesting to see more stuff be built on the health checks. So if you have ideas, definitely.
Do you care about REST linking at all?
About what?
REST linking, kind of like the last step version.
REST linking, so kind of in the more of the HOS aspect. Yeah, I mean, it's certainly there. It's possible that you can do it. There's nothing in Dropwizard that really supports or prevents you from doing it.
Your services are mostly service.
Yeah, in our services, we don't really do it. There's maybe one or two services running and playing around with it, but we really haven't had enough the internal developers clamoring for it that we've actually gone ahead and done it.
And also, like, we could do service transactions or something. So, transaction services.
So, thoughts on making services transactional so that transactions traverse multiple services?
So you basically build and send message out.
It's a very difficult thing to do, and at the moment we don't have any services that would really take advantage of that. So I don't see us in the near term spending any time on that. But again, if you have ideas you want to contribute back, it's open source. We'll take pull requests. Yeah, we have a limited number of services that actually talk to other services, and in most of those cases, it's not transaction oriented. So we just really haven't had a motivation to do it yet. Yeah.
Do you guys deploy Dropwizard services like your own data centers or EC2 or something? Where do most of your customers, what do they do for deployments? Where do they deploy? Do they use Roku or what do they do? Google App Engine? Their own things, do you know?
So we're not shrink wrap software. We run exclusively as a service. So we don't give the software to our customers to actually deploy.
No, but people that download Dropwizard to build their own services,
I see.
where do they deploy their services? I mean, you don't.
Man, no idea. Yeah, so we deploy predominantly to our own data center. That's going to be true for the next 12 months or so. We're currently in a non-Microsoft data center. We've got a lease that runs through the next 12 months, by which point we'll be wanting to move out and move to the Microsoft data center. There's some talk about whether we will run sort of more of the classical data center architecture, whether we move to something like Azure. We certainly, during hack days type things, we've deployed to Azure, we've deployed to EC2. So we've seen it running in other deployment environments, but we don't, most of our heavy deployments go into our own data center today. So there's no problem deploying into those environments, it does work. So,
Yeah, I would think you should be able to deploy to any kind of a Unix system or something like that.
Yeah.
I mean, where you're talking about init scripts and a command line Java app.
yeah, I mean, really anything that can run a JVM, you can deploy to. You can deploy it to a Windows VM if you really want to. Don't want to, but you could.
Actually, Azure does support Linux images, or actually Windows VM.
Yeah, the newest version of Azure Dashboard supports running Linux VMs. The older one doesn't. So if you find that you're running Azure and you can't actually launch a Linux VM, look for the new Azure Dashboard. You actually be able to launch Linux VMs. Something I learned a few weeks ago during one of our hack days. As I was sitting there pulling my hair out, thinking, I heard they do Linux, but all I see is Windows. What's going on? So how do our ops guys feel about Dropwizard? fact that all of the health check and all the metric stuff is centralized is great. They know exactly where to go find the stuff. The stuff that they, I wouldn't say hate, but dislike, is that some of the services don't behave exactly like other services. So this service has got one set of metrics that it wants to alert on. That service has another set of metrics that it wants to alert on. This one particular service generates only a small number of metrics. This service generates a ton of metrics. So when it comes time to things like when we want to begin importing those metrics into Ganglia, this one's got like 5 points that we're integrating into Ganglia. Oh, Ganglia can do that no problem. This one's got 8,000 data points per machine. Now suddenly Ganglia is starting to break a sweat. We don't like this anymore. It boils down to the service. It boils down to how good a run book we've given them in terms of being able to figure out, I'm beginning to get paged on this, what the hell does that mean, right? PC load letter, I don't know what the hell's wrong with this thing. It's really on a per service basis. With Dropwizard, they've got no concerns. With the per service, that's really where it comes in.
So on the 8,000 metrics, do you have any way to filter what metrics you get when you query the endpoint?
So when you query the endpoint today, no. What we end up doing is we don't actually use the Ganglia reporter that's currently in the open source distribution. We have a separate script that we call cephalopod. It runs a Rails script. It pings the URL endpoint. It gets back a lot of JSON. It picks out the metrics that it wants and forwards those to Ganglia. And so this is how we start filtering what actually makes it to Ganglia, so we don't blow it up and do a deploy. We did that with our messaging database because it has a couple hundred metrics per partition and 256 partitions and 45 machines. We brought Ganglia to its knees. Like all of a sudden they couldn't even get into the other services to see what was going on.
We found that too. So it seems to be a common story of you have to write some middleware that filters metrics that you use.
We actually, we were talking to some of the Netflix engineers because they have their own metrics library, and they were considering switching over to ours. One of the things that they need is they need the ability to filter and specify exactly what they want pushed into Amazon's, it's the Amazon metrics, CloudWatch. They actually wanted filters to be able to do that because they have very specific concerns around how much it's going to cost them, because Amazon charges you CloudWatch based on the number of metrics. And so they want to be very specific about which ones they push, to only push the ones that they'll actually have their autoscalers watching on. And so it was something that they wanted that we haven't actually supported yet. Yeah.
Yeah, question is about why Microsoft Online Backs Cloud Backs as opposed to Microsoft Enterprise Service in C#?
Yeah, so 2 questions. First one, why would Microsoft want to buy a bunch of Ruby on Rails and Java guys? Second one is Microsoft going to make us rewrite, or are they going to allow us to rewrite? So in terms of why Microsoft wants to buy us, the biggest reason is the product. The product and sort of our product and engineering disciplines. A lot of things that they've been citing for us. We're coming in under the SharePoint division, which is part of Microsoft Office. SharePoint is on a 3-year deploy cycle for their shrink wrap software. They are on, I think we were talking the other day, they said it takes them 3 months to do a deploy for their cloud-based solution. We can deploy every service we have, including the Rails code bases, in under a day. So we follow a much faster iteration cycle than they do. It's part of our DNA to get features out very quickly, run them through A/B tests, see how they're actually improving, how the user is using them, take the input feedback and use that to very quickly iterate on the product. One of the places where we've really been able to take it to our... different but similar. There's a lot of overlap between Yammer and SharePoint. There's a lot of talk right now about how the two are going to be integrated. So, to answer your other question about technologies, we've been told flat out we do not have to change any technologies. We can stay on Linux, we can stay on Java, we can stay on Rails, we can use whatever we want as long as we keep being successful like we have been. That's really what they want. They want to ensure long-term success. They don't want to come in and start screwing with us. Last week I was up here for the company meeting and also to give a talk on the Yammer architecture. And there were a number of engineers in the room who were like, wow, you use open source, which seems kind of weird to us, but oh my God, you're talking about your longest deploy takes an hour. Our longest deploy takes a month. So it's obvious to them that we're doing something right. They don't want to really screw with that and destroy the product in the process.
Are you moving to Seattle?
We are not moving to Seattle. In fact,
Are you hiring in Seattle?
So hiring in Seattle is a harder question to answer. I don't know right now. We're definitely hiring in San Francisco. We're not officially onboarded yet into Microsoft. The acquisition completed in late July, and they've been running through all the HR stuff. Our official onboarding date is October 1st. That's the point at which we'll start getting Microsoft paychecks. Everyone will have a badge. Everyone will be able to get on a Microsoft VPN. And at that point, we can start figuring out whether or not we start running remote developers out of Seattle, Redmond,
Are you in the city now in San Francisco?
Excuse me?
Are you in the city in San Francisco?
Yeah, so if you know where the San Francisco Giants ballpark is, we're about 2 blocks from there currently. We're in a building, we have 30,000 square feet, I think, in the building that we're in right now. We're bursting at the seams. We've taken on some additional space a few blocks away until the end of the year when we move into our new space, which is further into downtown, kind of in the financial area, where we're actually going to be in the same building as Twitter. So Microsoft is very gung-ho for us to get into our new space. We'll be moving into an 80,000 square foot space instead of the 30,000 that we have today. There are no plans to move any of us to Redmond. There's no plan to move out any of our engineers who are currently living in London. It's business as usual for us. So. Other questions? Fantastic.
All right. Well, thank you, Ryan.